We now once again have a technology presentation on lifetime extension of wind turbines. That's going to be by Mr. B.S. Nivedh, Business Leader APAC of UL Solutions.
About UL Solutions, UL Renewables have three wings. One is technical advisory, where we mainly work with all the different stakeholders from the project advisory point of view and also product level. And the second wing is testing, certification and inspection, where mainly we work on the testing and inspection services for any products within the renewable energy sector. And the last wing is the digital solutions, where we provide software, tools, and other digital solutions. Just one slide where you see how these three wings of our UL Renewables group is supporting the different stakeholders in the renewable industry, either a renewable project or a product, starting from the initial design stage or a feasibility analysis stage until the assets or a project after completion of its successful lifetime. How, until it is safely decommissioned, we are involved in each and every phases with different stakeholders by supporting them through advisory as well as testing, certification and inspection services. Before going to the subject of lifetime extension, I just want to mention a nice statement from one of my favorite book. Wind turbines are the perfect fatigue generation machines, which means this lifetime extension process or the entire exercise will be based on the structural integrity of the turbine. We'll be focusing on the structural integrity from the fatigue life point of view, and our interest area will be not on the performance or efficiency. Why lifetime extension? Normally, wind turbines are designed for a design lifetime of 20 years based on the standards we are following during the design evaluation process or during the design phase of the wind turbines. And on the right side, you see the different classification of the wind turbines according to the external conditions, load conditions on different wind sites. And this is mainly based on the extreme wind conditions as well as turbulence and annual average winds conditions. And this definition is coupled with purely based on the external conditions. It was assumed during the design stage. So once the design life is completed by the wind turbines, should we need to stop and dismantle the wind turbines, or what is the next step? So this is a good question. No, it depends on the wind turbine generator type or the design assumptions considered during the design stage, what all the initial design assumptions, and also that this turbine is designed for which wind conditions, and the operational history. During its operation of like 20 years, what the turbine have undergone, which are all the loads as well as the circumstances which has seen, and also the external conditions related to the site conditions, wind conditions and other conditions. So based on this, we will be able to come to a conclusion of whether we can extend the lifetime or not. So lifetime extension, as I mentioned, the turbines are designed for a particular design lifetime, normally 20 years. And this period is influenced by, as I mentioned, the initial design method which we considered, as well as the external conditions at site, as well as what it is designed for, which means the design assumptions initially. And the operational conditions, most of the turbines will go for curtailment, derated operations, which means the different power modes, as well as our O&M strategy will also be having different component replacement during that operational period, and also technical availabilities as well as downtimes. And countries like India, we also have this monsoon, and wherein only a particular period the turbine will be operated on the rated speed, and in the remaining period it will be on the ideal or in the low wind conditions. So these are all the different factors influenced, and we will be also calling this lifetime extension period also as a remaining useful life. And this exercise we will do for each structural relevant components. And this is purely an analytically derived parameter, which is like remaining useful life. Hence, this is purely depend on each turbine. The grouping of the turbine is not recommended, and these results are strongly connected to the operational history of each and every single wind turbine. And coming to the standard to be followed, UL 4143 is the standard for the lifetime extension of the wind turbines, and this is an ANSI standard. And also, more importantly, why it is relevant for India. In the last year, MNRE released a national repowering and life extension policy for the wind power projects. According to that particular guideline document, UL 4143 standard should be followed for certifying the lifetime extension of the projects in India. Coming to the standard as well as the process to be followed, it has two areas. One is the analytical study, and the second one is the risk analysis. In the analytical study, there are four areas. One is the external conditions, where the site wind conditions and other parameters we will be seeing, and operational conditions, the turbine, under which conditions the turbine was operated. And third one is, we need to find, or we need to derive a simulation model, loads model for the site as well as for the model, wind turbine model. And based on that, we will be calculating the remaining useful life of each structural component. And risk analysis have two parts. One is the inspection, because all this exercise we are doing based on the data and also desktop study. So we also have to see what is actually the condition of the wind turbine. And addition to that, there is also additional element which is design basis, which we can also, in addition to this standard process we can do, which is the design basis evaluation, wherein we can also evaluate any structural modifications. If we can do the lifetime can be further extended, or any operational modifications like derating or any special operational modes which we can follow, then again it can be extended further, or detailed load comparison also we can do in addition to the standard process. So this is the overview of the analytical study. The basic aim of the analytical study is calculate the remaining useful life for each structural component. For that, first one is we need the site model, which means the project. The layout as well as the entire environmental conditions has to be designed, which is site modeling, where we need topography as well as terrain complexity, maps, as well as the entire layout coordinates. And based on that, we will be able to model the site, project location. And we also have to create, based on the design of the wind turbine, we will be creating the independent aeroelastic model for the particular wind turbine model. And these two are, standard or generic. So to make it more representative to the actual turbine, we will be going through the SCADA data, and we will be able to, find out the downtime, technical availability, component exchange history, and also the different operational modes followed. And we can give this as an input to make it the purely representing that particular site as well as the turbine conditions. And based on that evaluation, we will be able to calculate, we will be able to find out the gap for each component wise, what was the initial load assumed during the design, as well as what was the real loads the turbine as well as the components faced during the operation. So that will be the outcome after this exercise. Now we have calculated or analytically derived the remaining useful life of the components, as well as we can consider the least value as a remaining useful life of the entire turbine. But we have done this exercise through data as well as based on several assumptions. So we also have to see what is the real condition of the wind turbine, so that we have to perform inspection. And normally this inspection includes complete rotor blade inspection through rope access or drones, as well as lightning protection system is also an important parameter we need to check as well as measure. And normally this demands the inspection has to be performed by 17020 accredited inspection bodies, or under the supervision of the certification body who is responsible for the certification of lifetime extension. Normally 25% of the wind turbine model generators we will be inspecting, and as well as after every year the remaining 25% we will be inspecting to maintain the validity of the certificate. And in this inspection, we will be focusing mainly on the structural integrity part, which means the cracks on the blades or any other structural components not related to other, O&M or performance-related inspection. Will not be focusing on this. And also, additionally, another aim of doing this inspection is also to validate, the data we received, like layout as well as coordinates, are representing the, really the turbine location as well as the other site-related conditions. So this entire exercise, consists of a lot of assumptions. Most of the informations or data are coming from customers, and we are not majorly relying on any measurements or independent measurements. Hence, it is also very important to know each document or each information we received, how accurate it is, as well as what is the severity. So we follow IEC standard to derive the risk analysis, and there are two parameters. One is the confidence level or the accuracy level of each information shared, and we rate it 1 to 10, as well as the severity of each document. Right? Based on this rating, we will derive a risk priority number. This risk priority number have a main role on coming up with what is the period which we can extend. Coming to the last important part, which are all the documentations required. As I mentioned, mainly three areas. One is external conditions or the site conditions. And the second one is the turbine related informations, load model, or the design data. And third one is the operational history, which means the SCADA. So we need the complete layout of the entire project which we are going to do this exercise, and construction approval mainly to see the commissioning data of each individual wind turbines, and also the other conditions with respect to the loads as well as the site assessment. These are all the informations related to the site. And coming to the design of the wind turbine, it is good to have the initial type certificate, including the drawings as well as the load model if it is already available. If the load model is not exist, we can also use the similar load model from the library of the tools, as well as we can change and we can make it more representative to this particular model by including the specs accordingly. And SCADA data, it is better to have 5 years of SCADA data for the last 5 years. It is better to have more data as well, but minimum 5 years of SCADA data is recommended. And also any structure relevant component replaced in this course of operational period, that information also very much important. And any other site changes, because that will have a direct impact on the loads, right? So considering the wake, so information related to the recent installations or dismantling, that also an important information we need. And finally, the assessment is purely depends on the data as well as information and also the accuracy level. So if you have more data, it is always important and better, because the quality of the information, results are strongly depend on the documentation availability as well as the accuracy of the documentation. So we have more data means we will be able to have more confidence and we can extend the lifetime further. But if you do not have much drawings or information related to the site or SCADA, that will have an impact on that risk priority number, and obviously it will reduce the lifetime extension period from the certification body side. Coming to the last point, our references, we have done this lifetime extension exercise for more than 30 gigawatt of the assets worldwide, globally, as well as we issued LTE certificates for more than 40 projects. And according to DIBT standard, which is the mandatory standard for Germany, we have assessed more than 1,000 turbines. And also we have the independent load models for more than 200 plus different wind turbine models. And these are all the different customers we worked globally. Yeah, that's all from my side. And in the rest of the time, if you have any questions, we can also have separate discussions. Thank you.
Thank you, Nivedh. I would like to request Mr. K.R. Nair to please join us here in presenting the memento. Thank you for sharing the services of your company. May I just request you to kindly step forward. Thank you.